All right. Yeah, hello everyone. Welcome to our next talk. We've got Brian Exelbierd joining us with his talk about the OS layer your platform ignores, and he will speak about taking care of Kubernetes nodes, file system matching, and like a lot of other cool Kubernetes stuff. So please welcome with a big applause, Brian.
Thank you very much. As I was introduced, I'm Brian Exelbierd. I work for Microsoft, and I'm telling you this for a couple reasons. The first is I work in Azure on upstream and community Linux, so I'm not a Kubernetes person. So any silliness that I do in Kubernetes today is my fault, not the fault of any tool that I'm going to be using. I'm using a couple of tools in this demo. One of them is going to be Azure. Doesn't matter that it's Azure. I happen to work for Microsoft. Very easy to get Azure access. But this works in any cloud provider you can think of. It works on any hypervisor you can think of. It works on this 2017 laptop. So there's no vendor there. The other thing that I'm going to be using today is another incubating project in CNCF called Headlamp as a graphical interface to Kubernetes, which I'm going to be running as part of my demo because I don't want to learn any commands. Let's get started. The slides are at this QR code if you need them. So this is the question that I want you to think about. You've got a lot of nodes. Can you prove they're all identical? Many people will think they can, but there's a lot of edge cases that crop up that cause us to not actually be able to answer this question accurately. And you can't generally do this below the, yeah, it'll run all my jobs level well. And there's a lot of reasons for that. A lot of it is because we tend to use traditional Linux systems underneath our Kubernetes nodes, and they are mutable systems, and mutable systems have the beautiful property of mutating, which means that old nodes will differ from new nodes. And there will be a problem, and an SRE will SSH in, and they will do something, and maybe they put in a binary that didn't go through your CI, or maybe they put in additional logging flags that aren't part of the system normally. And now that node is different. It may be something simple. They might just leave a log file or a TCP dump somewhere, and now the disk space utilization on that node is different, and you're cruising towards a failure because one node is now different. And all of this divergence that I'm talking about, it's all invisible. It's not visible through version numbers. You can see the same kernel, the same OS, the same kubelet, but there's still a difference. And in order to find that difference, you typically have to do a package-level audit of the system. You might even need to do a file system-level audit of the system. And we do have drift detection in Linux. We've had it for a long time, but it's detection, it's not prevention. And these audits, they don't scale well. When you're at 100 nodes, maybe. Go higher than that, not practical. Do it continuously, also probably not practical. You're going to cut your capacity seriously. So this isn't a Kubernetes problem. I want to be very clear about that. Kubernetes is really good at managing workloads, but it is very bad at managing nodes in terms of this deep level management of nodes. And there's really not inbuilt pieces of Kubernetes that do these kinds of health checks. Sure, you can do a kubelet health check, but that's going to tell you, is the system ready? Is it ready to take workload of that type? Not, is the system the same as all of the other nodes in its class? Basically, from wherever you look, these systems tend to look identical until they explode on you. So what should we do about this? The Kubernetes security community came up with this concept of shift down. There was a white paper released last year. I strongly encourage you to read it. The shift down community said, we already have shift left. Shift left is where we take security earlier in our pipeline and we solve problems before they get to production, before they get to deployment. We in-build those security promises and guarantees. Shift down posits that we should be taking that same concept and pushing security deeper into the platform layer. How do we make sure that the platform has the security promises and guarantees we want before deployment, before workload? Now, the folks who wrote shift down, they were talking about Kubernetes. I'm a Linux guy, right? I say shift all the way down. What if we could shift all the way down into the node OS? What if we could make it so that these kinds of drifts aren't just detected, but they become impossible? And this is built on good ground. Kubernetes has a long history, CNCF has a long history of doing the right work here. We've got Salsa, we've got SigStore, we have done amazing things with SBOMs and transparency. But again, all at the workload layer. Not a lot of it's hit Kubernetes at its actual deployment layer, and basically none of it has hit the OS. And a lot of the conversation is now focused on the Kubernetes layer and not the layer below it. And so I want to introduce you to Flatcar Linux. Flatcar is a CNCF project, which means it's community governed, vendor neutral. All the assets are owned by CNCF. It is a special purpose Linux operating system. All it does is run containers. It runs containers any way you want them run. It is an incubating project in CNCF, but incubation as a label here doesn't tell you a lot. It tells you a lot about CNCF and how long it's been in CNCF, but Flatcar actually has a very long history as an operating system. It started with something called CoreOS Container Linux, which took Chromium OS ideas about how to manage systems and built them into a real useful container Linux. Red Hat acquired CoreOS, that company, and they took Container Linux and they mashed it up with some other stuff at Red Hat, changed the tech stack. They've gone off and done great things. But another company called Kinvolk formed, and they took that original code base, forked it, named it Flatcar, and kept it going on the original technology line and concepts. Microsoft bought that company about 6 years ago, and then we have donated the operating system into CNCF. So incubating doesn't really tell the whole story here. So Flatcar is immutable, which means that user is read-only. We also dm-verity protect it. Dm-verity protection means that there's a set of hashes that walk through the entire set of blocks in the partition, and every time there's a read done, we compare that block to its hash, and we refuse to execute code that has changed. So if somebody managed to break your system, the hash would be screwed up, but also if you just get a cosmic bit flip, there's not going to be that kind of a problem either. The system's going to abort on that. It is not going to warn and then execute. Because it's immutable, there's no package manager in any traditional sense of the word. So installing things is difficult. You really can't install things. There is a process. I'm going to demo it for you. Updates are atomic, so this gets around that mutability issue because atomic updates means they are deterministic. You also have a very easy way to sanity check your nodes. Version IDs now mean something because the version ID is tied to the immutable user space. So if you compare version IDs, you can have a provable statement about these operating systems, or these nodes. Etsy is still writable. I want to disclose that. You can still get configuration drift. We are working on that. I'll tell you a little about that later. And this is, in my opinion, shift down, starting to be made foundational underneath your clusters. User space drift is not just detected here, it's just basically impossible. So I'm going to demo a couple things today. First, I want to show you what we're provisioning. This is a butane configuration. It's YAML. You transpile it into JSON because why not have two formats? And what you're going to do with this is define the contract between your workload and the operating system. Here I'm going to be using Kubernetes as my container execution. So I'm going to define that that's what I want. The project is going to deliver you an operating system that executes on that contract. So you don't configure Flatcar, you deploy Flatcar, and what you get back is the end result of your contract. So I'm going to use something like this. I've made some additions. The code will be online. Basically, I've got an SSH key. You probably wouldn't want that, but I need to SSH in, and a few other little things just to make the demo work. This is a single declarative file, though, so every system that I deploy from this declaration will look the same. They will all be identical. They will not drift. And I'm going to disclose this is the azcli command I'm going to run. I show it to you mostly so you can see that in user data, I'm just passing that transpiled JSON in. There's no magic here. It's not something mystical. A lot of providers can deploy against this same contract. So I'm going to start by seeing if you can read that. That is the wrong screen, but I hope you can read it. So I've got two nodes right now. I have a worker node and a control plane. This is headlamp. This is what I'd mentioned to you. I have cheated. It is running on my control plane so that when I take my workers down, it doesn't crash. But this just shows you I've got two nodes. I don't know why the memory displays like that. And let's see if I can do this. Okay. Can you read this? Good. Okay. I am a lazy demo guy, and so I'm going to start a new worker node, but I'm going to do it using a shell script that just builds with some seds the actual pieces I need to launch in Azure correctly, because otherwise I will never type this correctly. I do the same thing to build an SSH command, and I call it go, because again, I would never type all of the which key was I using in this demo environment stuff correctly. So, one of the things I had said to you was that there was this magical version ID. Let's take a look at it. When I practiced, I did not practice typing in this position. Sorry. So, we are running version 4593.2.0 of Flatcar. I'm told that our version numbers have to do with days from some special day. I have not bothered to look up what said special day is. I'm very sorry. But that's a version that we're running today. I told you that user was read-only. Look, I can't touch it, except I'm not root. So let's become root. Look, Ma, can't touch. It's a read-only file system. It's not giving me a permissions error. It is literally saying, you can't do this, sir. When I do a longer form of this talk, you can't remount it either. Don't worry, it really doesn't work. This is the dm-verity protection that I was talking about. This is the top hash of the hash tree that protects us. I'm actually going to copy this. Thanks to tmux, you cannot see highlights, but trust me, I copied it. And so this is what the hash looks like right now. What I want to show you, though, is it's almost up. We have worker 2. It's up enough. It's still joining the cluster, but like the system's running, and we don't need it to be in the cluster for this yet. Congratulations, welcome to worker 2. DM setup table. So that's our table, and we are about to see if they came out right. They did not. Uh-oh. Demo gods got me. Let's see if it came up with the wrong version on it. No. We will solve that in post. So, these should have been identical, and thanks to the demo gods, they are not. But you would be able to see that the version number and the hash were tied. I'm going to have to find out why Azure chose not to do that for me this time. That's the theory. We will keep going, though. One thing that I will show you right quick, I've got a basic deployment of Nginx running, and I'm going to scale that out just so you can see that worker 2 will, in fact, pick up workload, and we're all going to pretend the hash is matched. There you go. Worker 2 is picking up some workload. So, now that that live demo has failed, I will prepare you for the other two. It normally works. I am genuinely not sure why that did not come through, and I'm not going to debug in the 30 minutes that I have on this stage. What I am going to say is that that was weird, but we will talk about updates instead. So the way that you upgrade Flatcar is that you have two partitions, an active partition and an inactive partition. They happen to be named user A and user B. The naming is completely arbitrary. They could have been named Petter and Petra. I discourage you from doing that. But Flatcar doesn't do package level updates. Instead, it uses these two partitions to stage new versions of the operating system. So while your node is running on your policy, whenever you believe it's time to whatever version you choose, a new version of the operating system will be downloaded to the node. It will be written to the inactive partition and validated. At that point, only once all of those steps have completed does your running system do anything. And all it does is raise a flag that says, I'm ready to be updated. Updating is just a reboot. So in Kubernetes world, you'd want to drain, cordon, reboot, rejoin, pick up new workload. Rebooting is, again, done on your schedule. If you don't make any modifications, the system ships with a rule that says reboot as soon as something is available. You will learn this once you put in your first monitoring system. I did the hard way. There are a bunch of operators available, the Flatcar Linux update operator, curd, etc. Again, it all works with standard Kubernetes. It all updates as you're ready. And I will attempt to show you an update. So the first thing we need to do is to cordon that node. Let's use worker 1. Let's drain. We should see our workload move over. Ta-da! Okay. And now, are we back in 1? No, we are in 2. Let's go back to 1. Get my cursor back. All right, let's start by looking at our 2 update partitions. So these are our 2 partitions. As I said, they're arbitrarily named user A and user B. The highest priority partition that is successful is the one that we're running. So we happen to be on user A. We're going to boot over to user B. I will reconfirm version ID and etc OS release. We are still running 4593.2.0. And this system has already had the update staged so that you didn't have to watch me download things over the internet. And this is the flag that you get to see, that this machine needs to be rebooted because an update is available, and that we're going to go to 4593.2.1. So let's update. While the update runs, I'll share with you that Flatcar ships a bunch of different channels of the operating system at the same time. We ship an alpha, a beta, a stable, an LTS, and then occasionally we ship dailies. The reason I bring all of these up is not, ooh, look, we have channels. It's every single one of our channels is fully tested. So no matter what you grab, it has been fully tested with everything we know how to test with. But that goes further than most Linuxes. Most Linuxes run unit-lot tests. They'll test a package. Once or twice, they may test every package in the OS for a certain kind of build against itself. With Flatcar, we run over 100 end-to-end tests on every single release, from alpha on up. Those end-to-end tests are real tests. So it's spin up this cluster, run this workload, make sure this thing works. The real reason we use channels is it lets us gate features over time. It lets us ship incomplete features for users who want to keep up on other things or developers who want to keep working. And it gives us the opportunity for the community to participate by running canary nodes so that when you get to a stable release channel, those nodes have been tested not only by the project, but by users in the community over time. And so you're getting something that has survived both testing of depth and testing horizontally. So we should be able to get back into this node, and we should be able to look at our version again, and hooray, we have moved to 4593.2.1. And let's go put some load on that. Let's uncoordinate, and we will do our magical scale out again. And we should see Flatcar 1 pick up a worker here, or a pod here. There we go. So a question that I often get when I'm talking about Flatcar is, okay, this is great. Other than that failed demo, I love it. But how do I install anything? Because I do need things. And the answer is you don't install like any other operating system, a traditional mutable Linux. You don't package install. Instead, you use something called a systemd-sysext extension. It's an overlay FS that overlays /USR. You can think of it like a container layer, but at the operating system level. And these system extensions also have all of the supply chain guarantees of the operating system. They're immutable, they're dm-verity protected, they can be shipped on their own lifecycle or with the lifecycle of the underlying operating system. And they're just typically squash FSs that you overlay. They work the same way. You would typically want to drain cordon, but you don't have to reboot. You can do these live, and then you uncordon and put your workload back. We ship 3 different kinds of system extensions. There are 2 shipped by the project. They're really the same, but they have a difference, and then 1 shipped by the community. The project ships 2 or 3 of them by default. They are included in every image and enabled by default, so you have to opt out of those. Those are Containerd and Docker, and then in my case, there's an OEM for Azure with Azure tools. There's also OEM for Camu and so on, the tools that the various platforms underlying them need. There's also a set of extensions built by the project in time with each release that are official extensions that you opt into. And then we've built what we call the System Extension Bakery, where the community has come together to build additional extensions. I'm using some of those in this talk. That's where I'm getting my Kubernetes from. It's vanilla kubeatom. And it's also where, for example, I'm getting Tailscale from, because all of this is on a Tailscale tailnet so that it's not on public internet. But again, all of these are versioned, verifiable, and immutable, and have the same guarantees with regards to you can check one thing and make an assertion about all of the nodes that are using them. And nothing is installed here, it is all composed, as you'll see now. So once again, we're going to need to cordon that node, drain it. Do the thing, there we go. There, it moves over. And we are still on 1. So when I type correctly, you will see that we're running kubelet 133.2. In fact, what I can show you is that every node in this 3-node cluster is running 133.2. You can see it over here on the far right. Okay, so instead of a partition that changes back and forth, we use a symlink and etc extensions. And so you can see here I have 4 extensions loaded. I didn't bother to mark out Flatcar and Docker. So yes, there is a Docker binary on this system right now. Looks like it's just sitting in /USR, but it's really provided by my overlay. The same with kubelet. Kubernetes is linked to Kubernetes version 133.2. These are all being symlinked into extensions Kubernetes, which right now only contains that 133.2. The system can query for updates to those extensions. In this case, it's going to query and find them here. There's a version 12 ZStream available. I'm just going to take it even though it's candidate because we're in a demo. And I've already pre-staged that, so I didn't want you to have to watch it download, but there are tools that would download that for us. I'm going to copy that over to opt extensions Kubernetes, and then I'm going to force that symlink to change. Kubernetes 12, XC, extensions, Kubernetes. All right, I'm going to force that symlink to change. As I said, you don't have to reboot to do this. This can all be done live with just a refresh. So let me type the command correctly. sysext. So what it's going to do is unmerge user and then remerge user. And now man, I made a typo on both of them, didn't I? Now we have version 12 of kubelet. I need to actually restart kubelet on this system because the systemd unit file has always, and it would just never stop. And we can pop back over here, and you'll see we've already picked up version 12. We can uncordon this, and you can watch me scale one more time. And you'll see Flatcar Worker 1 pick up a node, or a pod. So this is all managed with a lifecycle file here. This tells it where to look for every one of these systemd-system extensions. In this case, we're monitoring the Z stream. This is what drives that command to be able to look. Again, this is all driven by your policy, your decision, your choices, not ours. So you decide that. I stepped into my demo a little early there. But what do we have? So what we have here is a non-research project, real thing used by actual companies. This is an older operating system than its presence in CNCF would indicate. We have real enterprise users, we have real community users. If you were paying attention to Open Source Summit North America earlier this week, Microsoft is using Flatcar as the pattern for the thing that we announced called Azure Container Linux. So there are real people paying attention to this. All of this tooling is Kubernetes standard. It uses cluster API concepts. Everything that I've talked about today can be done by Kubernetes operators, Daemonsets, and other pieces. I just did it all by hand for the purposes of the demo. This completely follows your policies. So if your node policy is we do one, or we do canaries, or we do this specific workload, and that's how we move through, great. If you're YOLO the whole fleet, great. Like, we don't have an opinion on that. I go YOLO. I did mention earlier that etc is writable, and so you can still get configuration drift, and that's a real challenge. And so we are working right now on incorporating systemd-conf-ext. Conf-ext is the idea of sysext, but configuration. So it will make etc immutable as well, and give you the ability to compose layers on top of etc. This will close the gap on this immutability piece and should leave us with the ability to take a look at the operating system's version, whatever we wind up with in conversation with the systemd folks about the configuration version, and then where all of the symlinks are pointing for our extensions. And from those simple data points, you can now reason across your entire fleet about the identical nature of all of your nodes, and that everything is configured as you actually want it to be, not just as random strings claim. So your implementation needs will vary, but this works, as I said, in any environment that you've got, under any Kubernetes that you've got. Thank you very much. I'm happy to take non-Kubernetes questions.
Thank you so much. And so we have already a bunch of questions that keep arriving. Let me just put up my brightest. Yeah, and it's already there. So any integration with Spiffy Spire?
Hold on.
I can read it. Oh, okay, yeah, it's an acronym, so it's better to read it out for your own.
I'm going to be very honest. I don't know what Spiffy and Spire are, so I am not qualified to answer that. But I forgot to put up the URL. If you'll visit flatcar.org, we'll put the slides back up at the end, I hope. If you visit flatcar.org, you will find our community of amazing human beings in documentation. We're on Matrix, Slack, CNCF Slack specifically, and Discord, and I'm sure that someone who is knowledgeable in those two spaces will be able to assist you.
All right.
Now we don't know the second question.
Yeah, the second question.
Do I like kittens? Yes.
Yeah, the second question is, can Flatcar be used to run stateful workloads with locally attached extra disks, preferably in LVM?
I know it will do it with network-attached disks. I am 99% certain you can do LVM without a problem.
All right, cool. It seems the Slido is reconnecting. Meanwhile, any questions from the audience? All right, Pavel. Right there.
No, no small dogs, just kittens.
Go for it.
Thanks for the talk. I have a question. Like, I don't update anything for a while. I just create a new node and replace the last one afterwards. So like, I can imagine the benefits in like physical environment where you have limited like nodes or limited resources. Like, is there any other benefits or reasons why I would prefer update over like new nodes and replacement?
That's really a matter of your policy. There are folks who, in certain environments, find it helpful to keep the same node around. As a terrible example, I would say perhaps you have a good deal on a certain SKU in public cloud. But many large installations drift towards that model where every node is simply recycled and nothing is updated in place. That also gives you better ability to do infrastructure as code and to test things through your CI pipeline. So in my opinion, use immutable, use Flatcar. That's a fantastic policy.
All right, thank you. Any additional questions from the audience? All right, so we have some more from Saldo. So can you compare Flatcar with Talos OS?
Yes, a little bit. So I have not run Talos personally, but Talos, as I understand it, and I am not trying to tell you what their project is, but I want to provide the background I believe I have. They are a unikernel project. I believe it's 7 or 12 binaries that they famously ship with. What they have done is taken a node and stripped it all the way back to a very specific use case, and it is API-driven only. That limits the applications it can be deployed into, but makes it fit as a special purpose operating system, that use case segment, very well. Flatcar is a bit broader towards general purpose, and so we have the ability to not only solve in the use case that they're in, but we can configure additional pieces that are not in their base OS. My understanding is that with Talos, it's pretty much a, if we didn't decide to put it in, you can't have it scenario. Whereas with Flatcar, between systemd-sysext extensions and the plethora of options that we ship with the extensions in the bakery and in the project, you can choose a lot of different things off the menu. As a personal example, remember, Linux guy, I use unorchestrated containers for all of my stuff. I run everything in Podman with quadlets because I happen to like that. The project provides me Flatcar out of the box running Podman.
All right, thank you. Does Flatcar support live booting via PXE on diskless machines?
Yes.
Okay, we've got that one answered. And what is the way for integrating proprietary kernel modules, for example, vGPU for GPU operator in Flatcar?
We do two things with that. With NVIDIA, we're building the modules and making them available. So they've got all the secure boot keys, et cetera, pieces signed correctly. And then the user space and other components are provided as system extensions. My understanding is that there are some folks working on delivering the modules themselves via system extension, but I don't think anybody has that working outside of the lab.
Yeah, good. Yeah, I think there's a follow-up question to this, right?
Yeah, thank you. Just to clarification, do you still need to rebuild the whole world, like Linux kernel, in case if you want to integrate proprietary model, or you just can inject it with ins-mod?
The way that we're doing NVIDIA, you inject it. That's because we have pre-built it ahead of time, and since the operating system's immutable, it didn't drift, so you don't have to rebuild against like whatever random libraries happen to be on that system. I cannot think of, it's DPMG, DPMK. Please help me, I can't think of the acronym.
DPMG, yeah.
Thank you. You don't have to do that. So you're not building this on every node every time, and you're not even having to set it up in your pipeline. We're providing that for you.
Yeah, I would like to put it, there are some options to get kernel modules from vendor. They're not publicly available, even for OS distributor.
Mm-hmm.
So they just give you source code with kernel headers, and you have to rebuild it. And the problem of using this approach with Talos Linux, you just need to rebuild the Linux kernel, sign this kernel module. And I was just thinking if it's solved somehow different way in Flatcar.
I'm not aware of that being solved as a recipe that people have published, but it may very well be. I don't tend to need those, so I personally don't have experience there. I'd encourage you to visit flatcar.org. Come see us, talk to us. But that being said, I suspect that the answer should be, don't quote me.
Yeah, thank you.
I would want the answer to be something like, pin to the release process, build a system extension that contains this module that's built at the same time as the release is built. The way that Flatcar releases are built, they're built in a containerized environment where there's 3 levels to separate you from what was inside the container, and then it bootstraps itself. It's Gen 2 based. And so I suspect you can inject into that process or append to that process the additional build that you need for this. That's what I would want to start with to answer that question. But I stopped being a developer a while ago, so you should not trust me on that answer beyond this is a good starting point for the conversation and community.
Thank you.
Thank you.
And
Thank
I
you,
think-
everybody. Sorry, not just that guy.
Yeah, and I think one last question. How about libraries, etc.? Are they symlinked the same way like binaries do?
I'm not sure I 100% follow this question, but the installation of the system itself looks to you the same as any other Linux, other than the fact that it is read-only. So once these overlays have come in, you can't tell what's being provided to you by an overlay layer versus what is in the base operating system itself. And that was like, when I typed witch doctor, it's just sitting in SBin. I can't know that it's coming in from the overlay without digging into the systemd-sysext extension configuration. I hope that answered the question. If not, I'm the person with the small child. You can find me afterwards. It is unexpectedly bring daughter to work day.
Thank you so much once again, Brian. Thank you for questions, and especially Brian. Big applause from Brian. Thank you.
Thank you all.